Okay, here we go. I hope you guys are ready to have a ridiculous amount of fun because that's what it's going to be. We're about ready to do some serious SolidWorks, and it's going to be superb. Let me tell you that. What you're looking at is an image of a Dove conditioner bottle. This bottle's been around a while. If you do an image search online, you're probably going to see a lot of images that look very similar to this. They really don't have a lot of perspective views or other views other than this front profile view online. You might have better luck than I did, but at any rate, this is about the best bottle image you're going to get. Now, what we're going to do today is start modeling this bottle, and as you might imagine, based on some of the things we talked about in class, it's best to approach this particular model with a master model technique. And that's because this, as you can tell, consists of what looks to be 3 parts, but in actuality is 2 parts. You have the main body up here, you have the cap down here, and the cap looks like it's consisting of 2 parts because it has this little flip open lid, which actually is like a living hinge flip open cap, which is technically molded in the same part. We can get into that a little bit later, some of the particulars that won't be covered in this particular video. But at any rate, what I want to talk about today is how to model the basic form of this bottle. Because this bottle consists of 2 different parts, 2 different manufactured parts, and it looks like once it's assembled, once you put the cap on the body, it looks like it's one single shape. Basically, the cap and the body, when they're joined together, create this nearly seamless kind of curved profile that melds together very cleanly. So because of this, because the cap and the body just kind of merge together cleanly like this, it's a very good candidate for the master model technique. So we're going to today just tackle this overall form of the bottle without trying to model this top portion and the bottom portion separately or model them as separate parts. And this should be familiar to you based on some of the in-class discussion we've had. And if you guys are still confused about it, feel free to let me know. You know I love to talk. So now I'm actually just going to get out of this image because, frankly, it's been rather boring to look at for the past 2.5 minutes. And now I'm going to show you the actual model we have. This is technically the beginnings of the master model that I had made several years ago. And as you can see, it definitely bears some resemblance to this image. Obviously, a couple things we don't want to look at when we look at this bottle. Number one, just be aware that this model was taken from a bottle that I had several years ago, but I never really measured. It was something I only had for a few minutes. I took a couple quick pictures of it, and then I was never able to measure off of it. So technically, a lot of this is done by eye. So not everything is 100% precise. Don't worry about that. This is going to be something that you can consider like a concept model, something that's not necessarily ready for production, but something that you might put in front of a marketing team in order to get feedback on a design. So, at any rate, I'm going to stop rotating this shortly and actually start diving into the particulars. But a couple things you got to be aware of. Obviously, this is made up of several curves, compound curved surfaces, actually, that are something that requires, or not always requires, but oftentimes would be more conducive to using SolidWorks surface modeling. And that's why we opened up this surface tab up here. You have to right click if you want to get it open. Right click on those tabs and hit surfaces. By default, it's usually not on. So like I said, right click on these tabs and open up the Surface tab. Because that's what we're going to be doing a fair amount of today is surfacing. Obviously, this is one of the reasons why you're in this class, SOLIDWORKS 3. So as you can see also, and this should be very obvious, this is a symmetrical design, which means the left and the right side are equal. And that also makes it a good candidate for modeling one half of the model and then mirroring it over. And what that does, obviously, is eliminate a lot of work. Technically, you're doing a fraction amount of the work that you'd be doing if you're trying to model both sides at once. I hope that makes sense to you. Now, without further ado, I just want to refer over here to the Feature Manager tree. Obviously, as you know, SOLIDWORKS is capable of showing the history in which the model was built. So fortunately, even though I already have built the model, I can roll this rollback bar all the way to the top and more or less show you step by step the procedures I used to create this model. A couple things to keep in mind though, as you know, if you've been using SOLIDWORKS for any amount of time, when you create sketch features or certain features up here, these elements end up collapsing underneath geometric features that you create. So technically, some of these sketches here are in some ways out of order because when I created the feature here, Surface Extrude and Boundary Surface 1, the sketch 1, 2, and all associated parent sketches collapse underneath the child feature, thus bringing them into an area which makes them look out of order. But there's a way around that, and maybe you're already aware of it, and I'll show you that soon enough. Another thing I should mention is something I've already mentioned to you before, this little arrow up here. I tend to keep it open. Obviously, there's reasons why. I can just quickly turn on and off these elements, either sketches, planes, etc. Features I can actually very quickly hide or show them. Another thing you got to be aware of are the surface body folders and solid body folders. I'll be referring back to them quite often, as you'll see. I need to get a drink of water. I'll be back with you probably in 1 second your time, about 10 seconds my time. That was good water. Yep, I just had a sip. So, yeah, I'm in danger of blabbing now because frankly I'm very tired, people. So I hope you feel bad for me because I'm doing this late at night after work when you guys are probably playing video games. It's a shame. It's a real shame. Anyway, what I'd like to do is start to tell you how I constructed this. As you know, I pretty much built this whole bottle as one form inside of one part. This part I named Dove Conditioner _ Master. And I put Master there because later on I'm going to be splitting apart the cap area and this body area into their own separate parts. But like I said, because these forms pretty much merge together, the cap and the body, and it looks like one continuous form, might as well make it in one file and then split it apart later. So at risk of sounding redundant, I just told you that. So let's roll back here, and you'll notice there's a few different ways to roll back. I can actually grab this rollback bar and scroll it up, or I can just right click a particular sketch or feature and then hit the rollback button there. So this pretty much tells me where I started, but if I scroll down to sketch 4, technically sketch 4 is not where I started. Just to let you know how the rollback bar works, you'll notice when I rolled back up here, most everything down in this region remained grayed out, but a few of these sketches are more dark, like black, and they're not faded out at all. And this is a little odd for people that don't really know what's going on, and of course you don't have to do this because you're looking at a blank model. But anyway, if I roll this rollback bar down right above the sketch 3, it will temporarily unabsorb the sketch 3 feature and pop it back into where it was originally created. And then same thing with sketch 1, sketch 2. If I roll these guys down, it will temporarily unabsorb those features. Oops, hit OK. And now if I roll back down, it looks like all these are now ready to access. A couple things you got to be aware of if you're working with a rollback bar later on in your career. If you roll back down underneath one of these features that these sketches created, those sketches will pop back underneath those features. So watch this. See, they pop back in now. So now I gotta kind of redo all of that. Pop those back out. And the reason why I'm doing this is, I would imagine you can guess. This is by popping and unabsorbing these features out from their child features that they created. I'm now able to see these sketches and planes in their more or less their original order of creation. So first thing I did was create sketch 1. And sketch 1 represents the very bottom of the bottle, the base on which it rests. All right. Then you'll notice I created a plane above that, and I created a second sketch, which is technically representing the part of the bottle which flares out. See how it's smaller down here at the base, but it comes up and it flares out. It's a bigger kind of elliptical shape in that area. So I made a bigger elliptical shape there. And I'll cover these in a moment. I'll go through these in more detail. I then made on the right plane a profile sketch of the shape of the right side of the bottle, and that shape you can't really see very well, unfortunately, in this image. You'll just have to trust me and create a shape which is very similar. But essentially, these splines that I created here represent the shape of the bottle if you were to slice it in half down the center plane. And we'll get to that more later. Then there's this line I created up here, and that line was essentially only to create this plane, and that plane was used to create looks like I'm missing one sketch. Hold on. Why is that not showing? Sketch 4, sketch 10. See, yes, a couple of those were not being unabsorbed like they should have been. I don't know why SOLIDWORKS didn't unabsorb all of them. So bear with me. Ah, okay, now sketch 10 is unabsorbed. That's good. So yeah, I did sketch 10 on that plane, and that represents this little contour up here, which, believe it or not, is a 2D sketch, and we'll get into that later. And then there's this little 3D sketch here, which represents this part of the bottle, which you would almost think is vertical, but in fact it moves forward. This edge moves forward as it moves up vertically, and then also as viewed from the front, it moves to the left as it moves up vertically. So it's a 3D sketch because it's got compound curved transitions. So just to let you know, you should start with sketch 1. And sketch 1, if you were to take a look at the sketch plane, I use the top plane. Of course, I showed that from Edit Sketch Plane, in case you didn't know. That technically allows you to switch the sketch plane of a given sketch if you use the wrong sketch plane. When you switch those sketch planes, chances are things are going to go crazy on you, though, if you got a lot of features after that. But anyway, I digress. So sketch 1 is that right there. So if we were to open up sketch 1, this is what I have. I have basically sketched an ellipse, which I trimmed off. You're only seeing half of the ellipse left over. But I sketched an ellipse, which is up here. And I gave the ellipse a dimension of 2.5 inches wide in the x-axis by 1.625 in the z-axis. And just if you need a little refresher on ellipses, obviously, this is what I did, more or less. And then I put a little center plane in there. And the reason why I split the ellipse in half is because, frankly, I didn't need to model the whole thing, because I was just doing a simple one half of the model that I mirror later. And as you saw, I used trim to closest from Trim Entities, and I just was able to cut that off. And you're able to dimension the entirety of the ellipse, even though it's half gone, because it kind of remembers that it was an ellipse even after you trimmed it. So, as always in these tutorials, this is for future reference as well, I would recommend you look very carefully at the relations that I put in. I centered this reference line, or what they call a construction line, or what they also call a center line. I put that line on the origin with a midpoint relation. It's vertical. It's what else is it? Yeah, well, it's coincident. The center of that line is coincident with the origin, so it's kind of symmetric in the front of the origin and behind the origin. And that, yes, that little red set of arrows, of course, represents the origin of the plane, which is related to the origin of the model, the 0, 0, 0, XYZ. All right, so that was drawn on the top plane. Good stuff. I next, like I said, added in a new plane. I, of course, went to reference geometry plane here. And if we edit the feature, you'll see I just clicked on the top plane and I offset it at 0.75 inches. And that's because, in my opinion, this looked to be about 0.75 inches from here to here. And I'm setting the plane at that height because that's kind of where the curvature changes between the cap and the body. It goes from moving out to moving back in. And that's also a natural place to put the plane due to there being a split that's going to happen later between the cap and the body. So that's a plane that ultimately will receive a sketch, which is sketch 2. And sketch 2 is pretty much the same thing as what I did on the original sketch. And this gray one back here, of course, is sketch 1. But this black one is technically what we're drawing now. And this represents the this sketch represents this area here. Forget about that little curve, that will come later when we do the rest of the master model. But basically, we're drawing the larger ellipse in that area because it moves up and it kind of moves out as it moves up. So this ellipse here has to be a bit larger. So it's 2.85 inches wide by 1.8 inches in the Z direction. All right, same kind of relations going on. I'm going to turn off plane 1, just, oops, I turned off sketch 1. I'm going to turn off plane 1 because we don't need to see it at this point. The next sketch I did was sketch 3. And sketch 3, like I said before, represents the shape of the front and the back of the bottle at the mid plane. So sketch 3 was actually drawn on the right plane, and that right plane represents basically the very middle of the bottle. If you were to slice through the bottle vertically, right at the mid plane of the bottle, that would be our right plane. And of course, that's a plane we're going to be mirroring across later. And so these curves that I'm creating here represent the basically the edge that you would get. Oops, hold on a second. Why did I move to perspective view? Okay. It represents the edges that you would get if you were to slice right down the middle of that bottle. And then looking at it from the right side of the bottle, that's about the curves that you would see. So take a good look at what I did here. I used a spline for the front, and that's a 3-point spline. I used also a 3-point spline for the back. And just so you know, that spline, the end point does have to be coincident with the point of this ellipse. Make sure that is actually point to point. The second point of the spline should be exactly coincident to the point of this ellipse. And, you know, the end point of this should be, 8 1/4 tall off the bottom and about 0.2 inches in from that outermost point, which is that point there. So 0.2 inches in. And then same thing back here. Make sure the point is on the point. Those two are connected. Those two are connected. And frankly, these dimensions are something you should follow as well. 9 inches tall there, 0.15 in. And that is setting us up to have this nice little inclined face up here in order to get that the kind of inclined face up here that you get in the photo. That is kind of setting us up. And this is a good time for me to just let you know, this is a good time to let you know that there are many different approaches you guys could take to sketching. You technically could sketch these lines first if you wanted, and then sketch these ellipses after and connect the ellipses to the lines. There's many different order of operations that can be taken with SolidWorks or any other CAD for that matter, and still get the job done. So the order in which I'm creating this might not be the order in which everybody else would, or someone else in particular might. So just keep that in mind. But I do feel this is a very stable way to build it. And so I recommend that all of you follow this method. Don't try to build these ellipses first and then, don't try to build these profile sketches first and then the ellipses. Try to follow the same order, just so that your model will behave similarly to mine. All right, so that is now bringing us to this. And what is this for? Well, this line technically is not going to be creating any geometry. It's more just a reference line, which is why I named it for top face plane. It's a reference line because it is going to generate a plane that is slanted, and that's this plane here. So we're making a new plane that's at a diagonal or at an incline. If we edit that feature, you'll see how we created it. Basically, I clicked on the right plane for one reference to create the new plane, and then I clicked on that new line to create that new plane. And what it did by default when selecting those two. It, of course, made it coincident to the line, which this new plane in blue is. It's coincident to that line I sketched. And it is perpendicular to the right plane. And yes, you could try these different options, but really when you have these two selected, what this create plane option or create plane feature is most likely going to do is try to create a perpendicular plane to the right plane on that line. So keep that in mind. This is one way to create a plane pretty simply. And the reason why I'm creating that plane is ultimately to create the shape that I need for the top of the bottle up here. And that would be, you know, this little arc and that back arc. That arc I'm going to draw on plane 5, and that is sketch 10. And just so you know, I'm going to turn off sketch 4, this one, because frankly it's not doing anything for us anymore. I'm just going to hide it, not turn it off. Hide it so it's out of view. And now we'll see sketch 10. Now sketch 10 represents, like I said, the edges, the top edges of the bottle. And this is how I dimension them. I basically, if I open up the sketch or edit it, you'll see it is 2 different splines. One spline here, a second spline here, and the endpoints of each spline are coincident here. And I made that endpoint 0.55 from this point as measured in this direction. And then I made it 0.3 from, I believe it was this point over here, but let's go normal 2. Take a look at the normal of that plane. Yeah, I selected that point down there. So if you take a look at that 0.3, it is actually 0.3 0.3 in from that point down there. So that represents the top edge of the bottle. And once again, bear in mind these relations. The endpoint of the spline must be on the endpoint of this edge, coincident. The endpoint of this spline must be on the endpoint of this edge, coincident. And the handle, in this case, because my plane when it was created kind of by default was rotated 90 degrees compared to what I would have expected, I used vertical. You might need to use horizontal depending on how this plane is oriented when you created it. But anyway, the basic idea is this handle is forced to go this direction, because if you don't do that, and this, if we were to delete that relation and delete this relation, you could end up accidentally creating this kind of scenario where your handles are not creating a nice perpendicular entrance to the midplane there. So when you mirror it, you're going to end up with a butt. And or you would end up with like a little sharp there. And maybe that's something I'll show a little later, the result in 3 dimensions. Discard changes and exit. I'm not going to save what I just did there. So that's what you should have by now. And then we're going to do a 3D sketch. And that 3D sketch, let me hide this plane in the meantime. Hold on, I've got a mosquito problem. I'll be back. Okay, I don't know where that mosquito went, but anyway. Here is a spline that is not a 2D sketch, it is a 3D sketch, and 3D sketches are found with a drop-down arrow underneath the regular sketch button, and 3D sketch is found here. And what 3D sketch allows you to do is create a sketch, of course, which is not bound to a 2-dimensional plane. This sketch can move any direction in every direction. In this case, what we've got is a 3-point spline, yet again, and that's because we're connecting 3 sections or 3 profiles. We have this one, of course, and we have this one. So we got 1, 2, and 3 points. And the thing is, each one of these sketches here has a point that you can snap the spline to. So one obviously point of the spline ends up on the endpoints of these, and another one's yet again coincident. And I don't know why the relations are not showing. That's why view sketch relations was turned off. But that's coincident, and this one is coincident. And like I said, that one is also coincident up there. The other thing you got to keep in mind is that these splines can go wacky very fast. If you try to move, I'm going to Control Z that, but if you try to move the spline in an isometric view like I am in right now, you see that yellow box that is kind of morphing as I move this handle. That's showing that the spline handle's moving in X, Y, and Z direction. So what looks maybe okay in one view is actually going to be a mistake, because when you rotate it, you find out, oh, wow, it didn't move exactly where I thought it was going to. And before you know it, your spline's all kind of messed up because it's only moving relative to the view you're looking at. So that's something you got to keep in mind with 3D splines. So typically what I do, let me just get out of there and not save that. But typically what I do with 3D splines, 3D sketches in general, is sometimes I'll be doing something like, I hit the space bar to bring this up. I don't know why this is so big. Hold on. All right, I'll use a 4-view window. And I have a front view, of course, top view, and a left view, and then my rotatable view here. And you can assign any one of these viewports any view that you want. But by doing this, you're able to see what's happening in each view. And when you're working in the front view, for instance, the handle will only move in the X and Y direction. When you're working in the top view, the handle will only move in the X and Z direction, as represented by the little axes down here for reference. Same thing with the left. If you move the handles, it's going to be in the Y and Z directions. So you're kind of constraining the motion of the handle based on which view you're working in. But honestly, the same thing can be done when you go to your single view and you just say, okay, I'm going to go to my top view. If you're working in your top view, the handles will only move XZ, move in the front view, only XY, etc. So what I try to do is get the spline looking good in one view, say the front view, and then move over to the right view, for instance, and get the spline looking good, and then maybe move back to the front view and yet again tweak it. And of course with splines, as you should know by now, you see these different parts of the spline have different kind of functionality. If you hit the very end point of the spline, you can move the strength of the spline handle, changing the curvature or acceleration of the spline in that area, and also the angle of the spline. So both things at once. If you hit the arrowhead, you're only able to change the acceleration or the strength of the spline. And if you hit these little perpendicular arrows, it only allows you to change the angle of that spline at that point. So that's how to kind of work with splines in a fairly controlled manner. Another thing with splines is you'll notice by default, oftentimes SOLIDWORKS has maintain internal continuity on as a check. And what that does, sometimes it's good to have on, and other times it kind of gets in the way. Sometimes it actually makes or causes the splines to behave or become less editable in a way that you don't really want. So I tend more often than not to turn off or uncheck maintain internal continuity. Play around with that and see what you get. So that is basically what we're doing here. As you can see, it's pretty obvious to me and probably to you at this point that we're basically creating like a little wireframe, like a little armature for our bottle. And this bottle kind of lends itself to this kind of technique because it's made up of fairly simple sides or fairly simple faces. All of these are like 4 sides. Basically, you've got 1 side, 2 sides, 3 sides, 4 sides, and then same thing on the back side. When you have a situation like this with very well-defined edges like this has, and you're not having a lot of crazy transitions between faces, it's actually probably a better approach to just take this approach where you're modeling by creating all your sketches first, creating like a little wireframe like I did here, and then filling in that wireframe with surfaces later. Yeah, I just got interrupted. I know you didn't realize that, but where was I? I was talking about wireframes. Yeah, so modeling something like this is actually a good idea to use this technique. In later classes, we will cover some different techniques on approaching certain models where you kind of overbuild the geometry and trim it away. But this model does lend itself to kind of directly creating the geometry through sketches right at their edges, and that's what we're doing. So the next step would be, and I forgot to actually show this one maybe. I'm going to unabsorb this sketch. Okay. The next step was sketch 4, and that is this, because this is kind of a bit of a straggler. As you can see, what we had before was obviously nothing defining the shape in the midsection on this top face. So we certainly need to do that, and that's what sketch 4 is doing. So sketch 4 is sketched on, yet again, the right side plane. And if you look at the sketch really quick, it's a 2-point spline. You don't really need a 3-point spline. Just 1 and 2, and then adjust your handles to get the curvature you want for the face. And yet again, you have to visualize what the bottle looks like if you were to slice it through the middle of the bottle. And honestly, it's hard to tell in this photo, but there is a bit of a convex form to this top face. It's not flat. It's kind of bubble-like. It blows out, so it's kind of like a convex compound curved surface. And because of that, if I turn or show the sketch, it is exactly how I drew it. It kind of blows out in the middle there. All right. And then ultimately this will fade into this area, which you'll see soon enough. Let me save. Well, you should save. I don't need to save because I've already saved this previously. Surface extrude is one thing. This is one thing that might confuse you, but I will show you anyway. Surface extrude 1. I basically took those 2 splines in the middle, and I did an extruded surface with them. Why did I do that? Well, it's kind of an older method, but it's something you'll see exactly why shortly. Sketch 3 in my case, the vertical edges, not vertical really, but the spline that are in a vertical orientation, those get extruded out, straight out, because when we create these surfaces over here on this half of the bottle, we want these surfaces, when they meet the middle of the bottle, when they meet the right plane, we want them to kind of be very smoothly related to the left side of the bottle that will come later when we mirror it. And when you create these reference surfaces, they're basically there so that when you create the new surface on the right side of the bottle will smoothly transition across the midplane, because these surfaces will be used as a reference for curvature as it meets the middle. So that honestly won't become clear until a little bit later. So I will leave them here, but I'll just turn them into transparent surfaces because of the reference. Hopefully those won't be too confusing in the background. Then the next step would be a boundary surface of this lower face. You might wonder why I didn't go all the way up, and I'll tell you why. It's because of this edge right here. If I went all the way up to the top, you would have this spline edge running all the way through the model. Whereas I wanted, if I was to hide these sketches, I wanted this bottom face to be very clean without any interruptions. This might make sense in a moment. Let me just continue to show you a couple things. If I look at the boundary surface 1, this is what's going on. For direction 1, oops, let me expand that again. For direction 1, I use sketch 1, which is that bottom profile. And then I use sketch 2, obviously, to build it up. Obviously, the geometry will interpolate between this one direction 1 sketch and the second direction 1 sketch. But obviously, by default, it won't look like it currently does right now, unless you have your direction 2 curves established and defined. And these direction 2 curves, what they're doing is basically telling SOLIDWORKS how to interpolate between this bottom profile sketch and this top profile sketch. Without these sketches, obviously, if I was to just clear them, this is what the surface would look like. It's close, but it's certainly not what we want. That straight transition is not what we want. So for direction 2, we say we want that sketch. We say we want this sketch. We say we want this edge as well. And you'll notice that I turned off the sketches that were here in the midplane, and I'm selecting the actual edges instead. For here and for here, I'm selecting the edges of the surface. Whenever you have an edge that is directly in line with a sketch, it's typically preferable to select the edge instead of the sketch in SOLIDWORKS. And I will tell you why that is right now, because you'll notice that obviously, as you may remember, possibly from your previous classes, it's pretty important when you're creating a surface to consider how that surface is meeting up with adjacent surfaces. And in this particular case, we have these reference surfaces that we created front and back, which are going to help us define this surface here, define its curvature in this middle portion. So what you really ought to have is this edge 1 selected, which is this front edge here, and you click this little drop down arrow and say tangency or curvature to face. Tangency is a little bit self-explanatory. It means the new surface at that edge, this new surface that we're creating, at this edge that is highlighted, edge 1, will be tangent to that edge, or tangent to the surface which is related to that edge, which means it will come in nice and smooth. Whereas edge 2, same thing. You can say tangency to face, because you want this new surface, as it wraps around and meets the middle, you want the curvature of this back here to be nice and tangent with this surface. Ultimately, the reason for this is when you mirror across later, when you mirror the one half of the bottle, you're going to be able to have a nice smooth transition across that midplane. You won't have any weird little seam line where the curvature does not match. By assigning these tangencies to these reference surfaces, you're basically causing a very smooth model to take place later when you mirror the surface across. If this doesn't make a lot of sense right now, then I would encourage you to, once you finish your model, take those tangencies off, like turn them back to none, and then see what happens when your model gets mirrored. Most likely it's not going to look as good. So the other thing you might recognize in your case, if you don't have trim by direction 1 on, the surface will want to be created all the way along the length of the direction 2 curves. That's because the thing is, with boundary surface, it just keeps following whatever sketches you're using until it reaches the end of those sketches. But as I said before, we don't really want to go up that high, and I'll show you why right now. Because if I don't have trim by direction 1 on, we end up getting, oops, oh, that's not the best example, but we end up getting this surface, and we're losing out on that bit, the edge there. So if we were to do it all in one shot, where we included sketch 3 in here, it would cause problems. And I'll maybe talk to you guys a little bit separately in class about that. So what I do is make sure trim by direction 1 is turned on. And what that does is it trims the surface wherever the direction 1 sketches end. So you only have these 2 sketches, so it trims off the surface at the ends of those sketches and doesn't allow it to continue running along the direction 2 curves. So make sure that is the case. By doing all the, oops, I did not save. Hold on one moment, please. Trim by direction 1, and let me hit the check mark. All right, so that's what you should have right there. Now for the next step, I would say you have to do boundary surface 2. And that is the top portion of the bottle, the upper faces. And this time you are involving the edges here that you created on the surface. And like I said before, try not to select the sketch that is here, hide the sketch, and instead select the edges. So this says open group. Well, the reason why it says open group is because there's like one edge and another edge that make up this complete curve. And you have to select them together using the selection manager, which of course is found here, selection manager. If you're going to select both this front edge and this back edge in one shot, use the selection manager. If you're unfamiliar with selection manager, let me know and I will explain it. Hopefully that's something you guys already know. But at any rate, what we're trying to do at this point is use this bottom curve to generate the bottom edge of the surface, and then we're trying to click and get this top set, or this top sketch, as your second direction 1 curve. So obviously the form interpolates between those two, And then to direct SOLIDWORKS on how to transition the form properly, we have to rely on the other direction 2 sketches. And if you guys are familiar with lofted surface, direction 1 is kind of like your profile sketches. Direction 2 is kind of like your guide curves. It's very, very analogous to that, but boundary surface is better, so just keep using that. And I'll explain why if you're curious in class. At any rate, I used this sketch here in the front, used the 3D sketch representing the edge over here, and I also selected the rear edge back here. And this time there's really there is a need to make sure trim by direction 1 is selected, because if you don't, see how it continues down along these direction 2 curves until the bottom, and then you have multiple surfaces. So yet again, trim by direction 1, and it will stop right there where it needs to stop. All right, so when all is said and done there, you have a surface here. There's one thing I neglected to mention though, briefly. You really ought to have here, for this edge at this point, you should have, yet again, tangency to face. And what that does is make this new surface tangent to this reference surface next to it. And same thing for the back edge, tangency to face. One other thing I neglected to mention earlier was typically when I'm doing boundary surfaces, I will turn on, underneath curvature display here, I will turn on mesh preview. And that way I can see how the surface is being generated. I can see the interpolation happening. And you can actually change the mesh density so that you can see more of the interpolated kind of curves that are happening. And this can tell you a lot regarding how healthy or how proper a surface is being built. So I would recommend you always turn on mesh preview so you can kind of see that for yourself. And then you can also possibly sometimes see a difference between when you say tangency to face and when you don't. Right now I turned off, I set the curvature setting to none for this edge. So if you watch these mesh curves, now I go tangency to face, they modified slightly. Now these curves are moving in at more of a perpendicular kind of direction to that midplane. And that's very hard to describe without showing you some more examples and without you guys not, experimenting a little yourself. So, yeah, I'm tired. So hopefully we'll wrap this up soon so I can go to bed. And you guys can finish. That would be a beautiful thing. So let me see here. That is that. We've got that all set. Oh crap, I think I forgot to. I was supposed to hit the check mark. My apologies. That'll just give me an excuse to show you different ways of doing this. See these little drop down boxes? This is another way to access those same options. Tangency to face. It's basically applying them in a different area. Now it applied them over here because they're all connected. Just different parts of the interface. Okay, so we do want to maintain that. Now I would recommend I would turn off these reference surfaces because they're just kind of getting in my way now. Same thing here. Let's see here. Surface extrude for smooth mirror. So I took now the sketch 4 and did an surface extrude straight out. And the reason for that is yet again the same reason I made these over here. It's so that I can generate a surface on this top that is going to be smoothly mirrored across. The next step is for me to create sketch 6. And you might be a little confused by this at first, but what's going on here is sketch 6 is sketched on the right plane. So yes, it is sketched on the right plane here. See that? And technically, all I did was draw a plane, not a plane, draw a line, which is coincident to that point. If I highlight, see that point over here? And it's coincident to this edge. And I would also just hide all these sketches from before because they're just kind of getting in the way of selecting edges. If you still have these sketches turned on, what can end up happening is you click a sketch instead of an edge. And like I said, when you have an edge and a sketch on each other, it's best to select the edge. So where did that go? Oh, I wanted to turn that one off too. All right, so we got that simple line. And then the last thing we have is a perpendicular relation, which is basically saying this line is perpendicular to that curve. And that's found over here, perpendicular. And the reason why we're creating that little line right now is basically it's just a reference line in order to create this next plane. And that plane is this plane. And the reason why we're creating that plane is, you'll see in a moment exactly why. But to create, just so you know, to create that plane, you actually have to click on the right plane. And then you click on that sketch. And like before, you saw earlier in the model, there's a new plane being created perpendicular to the right plane, located at that line. And that's the new plane that we want to be able to sketch on. Let me hide sketch 6 because it did its job in creating that plane. Let me rotate to a less awkward position. The next thing we're going to do is fill in the top face with a surface fill. And this leads me to let you know why we created that plane here, it's plane 4. I'm going to absorb sketch 7 here because sketch 7 was actually done next. So before you do the surface fill, build in sketch 7. And sketch 7 is sketched on that new plane. And the reason why I created that new plane is to create a nice clean line which goes from this corner and runs in a very clean direction to meet up with this edge. Kind of runs essentially perpendicular to this edge. This edge is running this way, and this edge is running essentially 90 degrees. If you're to measure between this edge and that line right here, it's 90 degrees, 90 degrees. And that's why we created a plane like that, using that sketch back there, is to create that clean connection between this point and that edge. Now, this line is here for reference. It's not really necessary, but it's there. I could show you how I made it. Technically, I don't really need to, but I will. Just so you know, underneath convert entities, if you hit this drop down arrow, there's this intersection curve. What this does is allows you to create a curve at the intersection of either two faces, two surfaces, a face and a plane, or two planes, or on and on it goes. Basically, wherever you have two faces or two face-like elements, wherever those intersect, a line will be drawn. So right now, we are in a 2D sketch on this plane 4 in my case. So if I click on this face, or this surface here, face, surface, same idea, it will draw a line on this surface where it intersects with the sketch plane that we're on. And if I hit check mark because I have this surface selected, it just drew a plane where the sketch, not a plane, it drew a line where the surface and the plane intersect. And you'll see uses for this later in your life, believe me. You'll see this crop up again for sure. This is just a very rudimentary use of it at this point in time, but it is something that you should be aware of exists. So the reason why I created it in this case is so that when I created this two-point spline here, the spline handle can be made basically tangent to this line. So this line, the spline can be made tangent, or the spline handle and the line can be made tangent. And that's something that you guys should remember when you're working with splines and you want to make a spline tangent to something else. You can make the actual spline itself tangent, or the spline handle, which is connected to whatever it is that you want to make it tangent to. The spline handle can be made tangent to that. It's a little confusing, yes, but the reality is you want this spline to be tangent to that line. So put that in. Make sure that you have the endpoint on this edge. Make sure that's really coincident. Absolutely. Make sure this point and this point are coincident, or else you'll get failure. So the reason why we're doing a surface fill now on this top face is because if you try anything else, it's going to be giving you problems. Specifically, surface fill gives you this really nice clean surface that is very, very, I guess you could say, standard and healthy, in that if you see this mesh preview that I put on here, all these little UV curves, is what they're called, direction 1 and direction 2 curves, are very cleanly, perpendicularly related to each other. And that's what you want to see with a surface. And surface fill does that with irregular shaped contours or gaps in surface geometry. So if you have like a three-sided shape, like 1, 2, and 3, which this is, surface fill is oftentimes a good candidate. And surface fill allows you to select all those edges which make up your, as they call it, patch boundary, and it fills that in. But if it weren't for sketch 7 that we created, on this plane as a constraint curve, we would be getting a surface that looks like that, and it looks like it's kind of collapsing over here. And that's why I created this line to begin with on plane 4, to use as a constraint curve to constrain the patch surface that's being created here, constrain it to the edge so it follows it. Now that creates a very nice looking surface, but one other thing you have to remember is, because this is going to get mirrored later, like we did for the boundary surfaces below, we have to be very, very conscious of this middle transition. And you see how we have these 3 edges that are selected? Well, this one in the middle is very important. These 2 edges should be just contact, and that is these 2 edges here, this one and this one. The surface that you're creating will just come up and contact those edges and do nothing more. But this edge in the middle, you want to do more than just contact. You actually want it to have a curvature relationship with this reference surface that you created. You could also do tangent, and that's okay, but in this case I would just use curvature. It's a little bit cleaner result in my case. If you have none, or just contact, in this case, look at what happens. And if you get rid of your constraint curve, delete, what happens is, with just regular old contact selected, the surface that you create just comes up to the middle and isn't really smoothly related across the middle, which would of course give you a very weird line when you mirror later. So at least you need to, with this edge, go to tangent or curvature, and that allows it to smoothly dive in. And then of course add the constraint curve. And that constraint curve forces it to continue arcing out all the way to that point. Let me know if you have any questions about this. This is something that is important, these little pieces of the pie. Let me see if I actually maintained all those. Yes, I did. Okay, so we're all set there. Now, I don't really need to see plane 4 anymore, so I'm going to hide that. I don't really need to see this middle surface for reference. I'll hide that. It's still up here. They're just hidden. So now we're getting pretty close to having half the bottle modeled, at least the master part. So the bottom face is something we got to do next because frankly, we got this opening. We kind of want to seal that off. That's very easily done with a surface plane. And a surface plane is just a very simple tool to use. It only works when all the edges that you select, the edges or the sketches that you select are basically lying on the same plane. If there are any edges that are not on the same plane as the other edges that you select, it will not work. You'd have to use a filled surface for that. But planar surface, you'll notice all I did was select edge 1 and edge 2, and it filled it in with a simple flat surface. Easy, no worries. A very lightweight feature. And I would encourage you to use planar surface as opposed to filled surface in this situation because it's just a lighter weight feature that takes up less file size. So as you can see, we have a bunch of surface bodies now. We've got some that we don't really need because they were just references and we don't need any longer, but we do have 4 which are useful to create the geometry of the bottle width. We've got the topmost face, the bottom face here, we have the upper faces, and we have the lower face. 4 separate bodies. Now we need to actually tie those bodies together. Pardon me. I need to go to bed. We got to tie those bodies together in order to basically do the rest of the master model. So to link these surfaces together, these separate bodies, we probably have to use a particular tool, and that tool is Surface Knit. And like the name of the tool, essentially what you're doing is knitting together separate surfaces to essentially fuse them and integrate them with each other so that they become the same body. So if you go to knit surface up here, like I did, and I'll edit the feature so you can see what I did, you just select all 4 surface bodies, and you could say merge entities, not a bad idea. There's also a create solid option here. You can try that, but guess what? It's not going to work. Why won't it create a solid right now? Because you have a gaping hole here. This cavity is open in the middle. So it's not going to create a solid. I'm sorry. As much as you would like it to, it won't. So you do have now, though, after you do that, you'll notice 1 single body from all of those surfaces, which used to be 4 separate bodies. And what that does for you is a couple good things. It sets us up in a good way for splitting the model apart into their own bodies. You know, It allows us to do a couple of things which you're about to see here next. Next thing is creating a fillet on that edge. And I did a variable fillet only because I thought there might be a chance I'd want to change the radius of curvature as it transitions from the top to the bottom. Chances are you can just use a normal fillet and it will work fine, but I used 0.125 and it gave me a pretty solid looking fillet there. And then I continued down and put a fillet on this one, and that fillet was a 0.08 inch fillet just on those edges on top. And then continuing down the tree, I applied a fillet, I believe, at the very bottom, and that fillet is here. And I believe that was a 0.015, 15 thousandths inch fillet. Then I basically, at this juncture, said, now's a good time to actually mirror this guy over, or girl, it's up to you. Mirror it to see what it looks like when both halves are together. And now it's starting to look like a real bottle, fortunately. If we add perspective, now we can get a better sense of, as a designer, what this thing is looking like. Not too shabby, it's working. But you'll notice there's one more thing. If you do a section view by clicking the button up here, the section view button, you'll notice that this is actually hollow, still surface body. And that, of course, is confirmed by coming up here to this folder and seeing, oh, surface body. It's still there. And like I said, technically, more often than not, and right now we're creating a master model, so it's not so important, but pretend that this was the final model that you wanted. You'd want this to be a solid. And in order to turn this surface into a solid, it's pretty easy. You just go up to thicken. And in this case, when I say thicken, I don't want to just do a thicken where it's a wall thickness being added, and it remains hollow with a wall thickness. I want this whole thing to be filled in with mass entirely. And if you have this thing knit properly without any gaps, you should see this right here pop up. This doesn't always appear unless you have an enclosed volume, which we do. Create solid from enclosed volume. So you check on that. If you don't check on that, otherwise it's going to create just a solid with a thin wall around the face, which is okay in some situations, but not right now. Instead, do create solid from enclosed volume. And now, if you take a look at your folders, you now have a solid bodies folder with that in there as a solid body. And if you look at your section view, you now have a legitimate solid model. And this is not a bad thing, particularly when we want to do some things in the next video. And I know everybody's looking forward to it. It's going to be even more thrilling and riveting than this video was here. I'm telling you guys, if you are not like giggling like little girls at this point in time, based on all the fun that you had during the course of this video, I don't know what's wrong with you. You really should just be ecstatic, because this was probably the most exciting YouTube video you've watched in at least a good 2 months. So please be happy you came to class today and were able to enjoy such a riveting piece of history in the making. I'm tired and I'm going to bed. And guess what? This will be continued in the very near future. And hopefully any questions that you have will be answered during class. Take care, guys. Bye.